How are you all? I hope you're all fit and fine as you're all ready to learn. So today we are going to discuss basics points which are might not be seen significant to you in the chapter matrices, but these play an important role in the matrices. So in the first one we have equal matrices. What are equal matrices? As the name itself suggests, those matrices which are said to be equal if they are of the same order and each element of A is equal to every corresponding element of B. It means Aij is equals to Bij for all I and j. Let me tell you clearly, my friends, those matrices are said to be equal if they are of the same order, means they should be having the same order like m by n or any order of that matrix. They should be having the same order. Both the matrices or any number of matrices given should be of the same order, and each element of matrix first one is or should be equal to every corresponding element of matrix B or any matrix given in the second one. So here we have A and B, A as the first and B is the second. So Aij, an element Aij of the matrix A should be equal to an element Bij of matrix B for all I and j. Let's go by the example to get the clear picture of it. And here we have an example matrix A having an elements as 2 3 0 and 1, and matrix B having elements as 2 3 0 and 1. Here we can see 2, the corresponding element of 2 is 2 here, same one, that same one, that is the position of A11, and at the place of A12, that is 3, in the matrix B also we have A1, at A12 we have 3 only, and at the position of A21, that is second row and first column, we have 0 here. So and same applies for the matrix B also, we have 0 here at the place of A21, and A22, that is we have 1 here at that place, and that same applies here also, that in this also we have 1 at the place of A22. So by equating them, and we can see by comparing them, we can see that the corresponding elements are equal as seen in both the matrices, means each corresponding elements are equal, so A is equals to B. Mind you, my friends, if two given matrices are equal, then their denotions, that is A and B, can be written as A is equals to B. It cannot be only A and B, it can be any alphabet, but it should be capital letter, as I have told you in the introduction itself. So next in the line we have comparable matrices. Comparable matrices in which, as the name itself suggests us, that what comparable means, it can be compared. So two matrices can be compared only if they are of the same order. Here, my friends, we have one condition, that is they should be having the same order, means those both the matrices of the should be of the same order. And here we don't get a result like greater than, less than, greater than or equals to, or lesser than or equals to. It means to say that here at the conclusion we don't get a result like those the matrix A is greater than or less than, or greater than or equal to, or less than or equals to matrix B, but we compare two matrices to equate them. Just we compare the two matrices to just equate them and get the values of x and y. As we can get this clear picture by seeing this example. In matrix A we have 1 x 5 and y, and in matrix B we have z 3 5 and 4. Mind you, my friends, here it says that the first condition, they should be of the same order, means if they are of the same order, means here we have matrix A having the order of 2 by 2 and matrix B having the order of 2 by 2. So it satisfies the first condition here given, that they are of the same order. Next in the line we compare both. Why we compare both? To get the values of x, y and z as given here. In this x, y and here z, we are unknown, we are not knowing the values of x, y and z. So by equating them, if they are equal, then we must be equating them and we can find out the values of x, y and z. So by equating them, we can see at the position of a12, that is x position, so we have 3 here in the matrix B, so we can say x is equals to 3. And same applies for the y. At the position of A22 in matrix A we have y, and in same applies here for matrix B, that is at the position of A22 we have 4, so we can say y is equals to 4 if and only if A is equals to B. So same applies for the z also. In the matrix B at the position A11 we have z, and in matrix A at the position of A11 we have 1, so we can say z is equals to 1 as matrix A is equals to matrix B. So matrix B also would be and has to be equal to A. So we can say x is equals to 3, y is equals to 4 and z equals to 1 from the above given both the matrices. Next in the queue, we have construction of a matrix. Mind you, my friends, construction of a matrix. Here we will learn how a matrix is constructed or how a matrix is formed. So, in the first, we make a demo matrix as per the order of the matrix. You must be wondering what's a demo matrix. Then let me tell you clearly that demo matrix is a matrix having no elements, but it signifies the elements of the matrix. Means in a matrix we cannot have any element, but it just signifies the positions of the matrix. Here we have a11, a12, a21 and a22. They signify, just they indicate that and matrix should be of the order 2 by 2, and it should be having four elements inside it. So the first rule says we make a demo matrix as per the order of the matrix. And the second, in the second, we just substitute the values of I and j in a sequence, either row wise or column wise, to get the element of the matrix. So here what we do, we just substitute the values of I and j. I and j means 1 and 1. Here I is equals to 1 and j is equals to 1. Here in this position we have I is equals to 1 and j is equals to 2. The first one is the I and the second one is the j. The first digit here is the I, that is 2, and the second digit here is the j, that is 1. And here also applies the same. The first digit here is 2, that is I, and j, it is 2. So we have the matrix A of the order 2 by 2, which is a demo matrix as per the given order. Here we go by starting with the question. The question says construct a 2 by 2 matrix whose elements are given by aij is equals to I plus j whole square. Not only this, it can be anything here. It can be even I plus j only, or it can be even I plus j by whole by 2, or any operation it can be given here. So we just have to substitute the values of I and j in this formula to get the element of the matrix. So if you go by this I plus j whole square, then here we have a11 means I is equals to 1, j is equals to 1. So 1 plus 1. 1 plus 1 whole square is equals to 4. That is 2 whole square is equals to 4. And same applies for a12, that is 1 plus 2 whole square. 1 plus 2, mind you my friends, here we get this 1 plus 2 from this position. So 1 plus 2 whole square is equals to 3. Whole square is equals to 9. And same applies for a21, that is 2 plus 1 whole square, that is 9. And same for a22, that is I and j both are 2 2. So 2 plus 2 whole square is equals to 4 whole square, that is 16. So the given matrix is, now what we do to get the matrix of the resultant, what we do is to, what the values we have got at the particular positions, we just substitute them at the required positions in the demo matrix to get the answer as the proper matrix. So what we have done here, we have substituted the values of a11 at 1, a11, that is 4, a12 at a12, that is 9, a21, that is 9 at the position of a21, and a22, that is 16 at the position of a22. And here we get a matrix A which is ready, and it is matrix of order 2 by 2, and it has elements as 4, 9, 9 and 16. So next in the line we have operations of matrices. Mind you my friends, operations. Here we, in this video, we'll be learning only the difference of matrices, and next all the operations we'll be learning in our next videos. So difference of matrices means, as the name suggests, difference means we get the subtraction of two matrices. Here given matrices should be of the same order. To find out the difference of two matrices which should be given in the question or any asked place, so they should be of the same order. They should be satisfying the condition that they should be of the same order. And then difference is obtained by subtracting the corresponding elements of both the matrices. How we get the difference, friends? It says here how we get the difference. Difference is obtained by subtracting the corresponding element of both the matrices. Corresponding elements means one to one corresponding in the both the matrices. As we go by the positions, in this example we have 5, 6, 7, 8 as the matrix, as the element of the matrix order A, order 2 by 2 of a matrix A, and B we have 1, 2, 3, 4 as the elements of the matrix 2 by 2, which is called as matrix B. Then find A minus B. What is the question, what is given here as a third point is resultant is also a matrix of same order. Means what we get at the conclusion after the subtracting the first matrix from the second matrix, that is resultant, and that resultant is also a matrix of same order. Means what order the given matrices are of, and that same order would be the resultant also. So in the example we get A minus B. Find the as the question says, find A minus B. So A minus B is equals to 5 minus 1. That is for the first element. Here we have first a11, so corresponding elements 5 and 1, we subtract them. 5 minus 1, corresponding elements 6 and 2, for both the matrices we have 6 minus 2, and here 7 minus 3, so 7 minus 3, and next 8 minus 4, corresponding elements of a and b, that is 8 minus 4. So let's assume a minus b is equals to c, then c is equals to 4 4 4 4, as we get 5 minus 1 is equals to 4, 6 minus 2 is equals to 4, 7 minus 3 is equals to 4, and 8 minus 4 is equals to 4. So we can say that the resultant is also a matrix of the same order. Okay, 2 by 2 as the given in the question. They both are of the same order, as the first condition itself says that given matrix should be of the same order. So here we have two matrices of the same order. And next here, difference is obtained by subtracting the corresponding elements of the both the matrices. Means here we get both the matrices get subtracted here by the corresponding elements, and then we get it as the resultant. As we have, resultant also says that is also a matrix of same order. Means here we have this matrix C is equals to 4 4 4 4 as the order of 2 by 2, same order and same matrix, and is also a matrix of same order. So with this, I hope you have learned something. With this, I'm taking leave of you. Thank you, and from my side, Jai Hind. Next operations we will be learning our next videos.